friends, I am Vaibhav Srivastava from Vaibhav E-Learning Academy. Today we are going to continue our topic vectors. This is our part number 2. So in the previous video we have learned about what is vector, what are scalars, what are physical quantities and what are the types of vectors. So in today's video we are going to learn about resolution of vectors and then parallel shifting of vectors, addition of vectors. We'll be learning about the 3 laws of vectors and then we'll do some problems. So let us start with the most easy topic. The most easy topic is resolution of a vector. So as we all know, this is the head of the vector and this is the tail of the vector. So this is a vector. This is how you represent a vector. The head of the vector points the way the vector is facing and the tail says what is the magnitude of the vector. So in the previous class we had learned any quantity which has direction and magnitude and also obeys vector law of addition. We also discussed about vector's law of addition. So that vector's law of addition, there are 3 laws which we'll be discussing today. So let us start with the resolution of vector. So before moving on, you must know that what are coordinate system. So let us take this as a graph. So here this side is positive x-axis, this side is negative x-axis. This side is positive y-axis, this side is negative y-axis. There is also one axis which is actually formed over here. This is called the z-axis. So in vectors, especially in unit vector, we have discussed about unit vector. There will be a separate video about unit vector. So in unit vector, this x-axis is replaced by I cap and y-axis is replaced by j cap and z-axis is replaced by k cap. These are the basic. We'll be learning about more about them in the other videos, which will be about unit vector. So this is the x-axis, y-axis and z-axis which will be coming outside and inside. So if we take a graph like this and if you put one vector over here, so this is the x-axis, this is the y-axis. From the y-axis, if we are like taking another vector and putting it up at an angle theta. So at an angle theta, if you are taking a vector from the x-axis and you are pointing it upside, note that to find the resolution of vector, you must see where the theta is. Because if the location of theta changes, the resolution of the vector changes. So the questions may come like find the resolution of this particular vector with respect to x-axis or with respect to y-axis. To find that, you need to know that this totally makes 90 degree. This total, it makes 90 degree. If they have given some values, they will give some value for theta. Let's say 60 degrees. So if you know this is theta, this is the 90 degree and let us take this as alpha. To find alpha, you need 90 minus 60 degree, which will give you 30 degree. Thus alpha is equals to 30 degree. This value is 30 degree and this value is 60 degree. Totally it makes 90 degree. So to find the resolution of vector, you need to first see where the theta is. So in this case, our theta is over here. Now to find the theta, like to find the resolution of vector with respect to x-axis, wherever the theta is there, you need to take that as cos theta. So this vector I am taking it as u bar. This vector is a u bar vector. To find the resolution of the u bar with respect to the x-axis, wherever the theta is there, that side you need to take u cos theta. And the perpendicular side, like this is the x-axis, the perpendicular side which is the y-axis, you need to take this area as sin theta. So this will be u sin theta, or you can see this as u sin theta. This is how you find resolution of a vector. So if any here a vector u bar and this is the theta, so with respect to x-axis you get u cos theta, and this side if you have to find with respect to the y-axis you get u sin theta. So this is how you can find a resolution of a vector. Let us take another case. Let us take a case, this is the same like that. Here we have the vector u bar, but this time we are taking the theta here. So which side will be the cos theta? Correct. The cos theta will be this side. So here will be the u cos theta and the perpendicular to this, which is this one, this will become u sin theta. This is how you find the resolution of the vector. So to find the resolution of the vector, first find which side is the theta, and after finding which side is the theta, you have to take the theta side as the cos theta and its perpendicular side as the sin theta. So this was the concept of resolution of vector. Now we'll do some problems regarding resolution of a vector. So let us see some problems regarding resolution of vector. A car is moving with 100 km per hour with 30 degrees towards east. Find its components along x, east and north. Like here, east we are going to take x-axis and north y-axis. So in reality, we cannot say that the north is that side, or like north, you can't point upwards. So in reality, the north is like that, behind east, and if the north is that side, north, south, east and then west. But when you are taking a paper, when you are taking a 2D place, you cannot imaginarily draw everything. So you take this as north, this as south, this as east and this as west. So over here, a car is moving with 100 km per hour with 30 degrees towards east. So towards east, here we are taking x-axis, this is as y-axis. Towards east like this, and here the u value they have given 100 km per hour and 30 degrees towards east. So here 30 degrees. Now we need to find its components along east and north. East is the x-axis, north is the y-axis. X, y. So to find its components along east, first we take. So we saw that the theta is over here. Wherever the theta is there, at that base, that adjacent one, you have to take as cos theta. So u cos theta, here you will get u cos theta, which is equals to u values they have given 100 into cos theta is 30 degree. 100 into cos theta value is root 3 by 2. 2 ones are 2 50s are. So you get 50 root 3. So this is u cos theta, which is equals to 50 root 3. I have said you that if it is at x-axis, it is called I cap. So here we are going to take I cap. Now over here we have u sin theta. So u is equals to again 100 into sin theta is equal to 30 degree. So it is equals to 100 into sin 30 is 1 by 2. 2 ones are, 2 50s are. So here you get 50 j cap. So this is what you get, 50 root 3 I cap and 50 j cap. So the x-axis you get 50 root 3 I cap. Y-axis you get 50 j cap. To write this in the answer way, you can write as 50 root 3 plus I cap plus 50 j cap kilometer per hour. So this is the solution for this question. A car is moving with 100 km per hour, 100 km per hour with 30 degree towards east. Theta over here is 30 degree. Find its component along east and north. So here we have taken east as x-axis, north as y-axis. So u cos theta is equals to u given is 100. 100 into cos 30 is root 3 by 2. 2 ones are to 50s are. So here we get 50 root 3. So here we wrote the value 50 root 3 for I cap. And for j cap we have u sin theta, u is equals to 100. So 100 into sin 30 degrees is equals to 100 into 1 by 2 is equals to 50. So your answer is 50 root 3 I cap plus 50 j cap. So you can take that 50 root 3 is the component of the vector. So see, how do you find the component? Like these things, you draw a perpendicular around it. So this over here is the component along y-axis, this over here is the component along y and x-axis. So along x-axis the component is 50 root 3 and along y-axis the component is 50. So now we are going to learn about simple addition and the addition of vectors, and simple addition and vector addition. We will be discussing about them in vectors. So let us see. So now we are going to learn about the addition of vectors. So we have an example question over here. A bar is equals to 2i cap plus 3j cap plus 4k cap, and b bar is equals to 4i cap minus 6j cap minus 7k cap. So here we are going to find the magnitude of a bar plus b bar. So here if they give a bar plus b bar, you can just simply add them. But here they are given this symbol. Now if you take a value a and if you put this around it, it is called mod. This symbol is called mod, and finding the mod, this thing, you call it as magnitude. So if you have a vector a bar, So A bar can be represented as this. But if you want to find the magnitude of the vector, then you put a mod around it. So this mod represents that we do not need direction, we only need the magnitude. Like 2 I cap. So the magnitude of 2 I cap is only 2. But if you are taking a vector, you don't have to take 2 I cap plus 3 j cap plus 4 k cap. So to find the magnitude, you have to take under root of x I cap plus y j cap plus z k cap. Under root, like even if we have subtraction, we have to only use plus. So this over here you can call that it is the magnitude. Like this you can find the magnitude. Now in vector there is an amazing thing, that normally you know that A bar, like A plus B, is equals to C bar. But in vectors we do not take C bar. In vectors, like what if there is 3 vectors, then you can't write D bar, right? So we take one value which is called R bar. Now R bar means resultant vector. So R bar means the resultant vector. So the resultant of A bar plus B bar is equals to R bar. So what is the resultant? If you put A bar plus B bar as a mod, then it means that you are putting mod around the resultant bar. So over here, A bar plus B bar is under a mod. It means you have to find the magnitude of A bar plus B bar. A bar plus B bar is equals to R bar. So this means that you have to find the magnitude of the R bar. So what is the step? How can you find the magnitude of this question? First, you have to add both the vectors, because you have to find the magnitude of addition of both the vectors. So add them. How do you add them? You have to add the like vectors, like which have like I cap, add them. J cap, add them. K cap, add them. So 2 I cap plus 4 I cap. 6 I cap. Plus 3 I cap minus 6. Minus is greater, so plus and minus minus. 6 minus 3 is equal to 3. Minus 3 j cap. And plus 4 minus 7, which is equals to minus 3 k cap. Now, we got here this as the R bar. So the resultant vector is 6 I cap minus 3 j cap minus 3 k cap. But now we have to find the mod of the resultant vector. If there is just A plus B bar, then this answer is the correct answer. But we have to find the magnitude of them. So magnitude is equals to under root of 6 I cap, right? We take 6 square plus 3 I cap, right? So like 3 j cap, right? So 3 square is equals to like 3 square we take. We have to take the squares. We don't have to take the number. We have to take the square. And minus 3, even though it is minus, you have to take square positive only. 3 square is equals to 3 square. So under root of 6 square is equals to 36 plus 3 square 9 plus 3 square 9. So here you will get 9 plus 9 18 and 36 plus 18 is equals to 54. So under root 54 should be your answer for this question. So A bar is given some 2 I cap plus 3 j cap plus 4 k cap. B bar is given as 4 I cap minus 6 j cap minus 7 k cap. So we have to first find the R bar. R bar means you have to add both the vectors. After adding, you get this. This vector you do not need to name C bar. You can name it as R bar. Find the magnitude of R bar. You have to use under root of squares, like square of each vector. And then you get the answer as 54, root 54. So this is how and normal addition will be. But now we'll be learning about the laws of vector addition. There are 3 main laws of vector addition. The first main law is triangular law, the second law is parallelogram law, and the third law is polygonal law. Let us see all these laws one by one. So now we are going to discuss about the laws of vector addition. So basically there are 3 laws of vector addition. So 3 laws of vector addition, starting with the first one, which is the triangular law. Triangular law. The second one is parallelogram law. Parallelogram law. And the third one is the polygonal law. Polygonal law. So let us start with the triangular law. So let us take like the statement of the triangular law. For example, you have 2 vectors like this. Here we can take this as A bar, B bar. So the statement of this question, like this triangular law, is that if two vectors represent 2 sides of a triangle, then taken like the 2 vectors in 2 sides of a triangle taken in continuous order, then the third vector is taken in the opposite order. So how can you explain this question? Like how do you understand with this one? So let us take two vectors over here as A bar. Then we have this one as B bar. So if two vectors A bar and B bar represent two sides of a triangle, one side, two sides of a triangle, taken in same order in the sense tail to head, then again tail to head, like that, like tail, head, then again tail, head, tail, head. Tail and head are attached, like tail and head are joined together. Then the third side, like the resultant bar, that is the third side, is taken in the opposite order, that is like this. If from here this is tail, this is head, this is tail, this is head, then instead of going down back again, we have to take the C bar, or we can take here R bar, in the opposite manner. So here it can be like this, it can also be like a right angle triangle. In most of the cases it will form a right angle triangle because this may be the A bar, this is the B bar, and the resultant you will have to take like this. Then they'll give you the value of A bar, they'll give you the value of B bar. You have to find the value of R bar. And how can you find the value of R bar? Obviously using Pythagoras theorem, because this is the first side, this is the second side, this is the hypotenuse. So if you take this as the theta, this is the opposite, this is the base, and this is the hypotenuse side. To find the hypotenuse side, you have to use the Pythagoras theorem. So what does the Pythagoras theorem state? So for example, this is a triangle, right angle triangle. So this is A, this is B, this is the theta, then this will be the opposite, this will be the base, this will be the hypotenuse. So Pythagoras theorem states that AC square is equals to AB square plus BC square. Using this, here we have our AC square as R bar, so we can take here like R square is equals to AB square as A bar plus, like we have to take the magnitude, right? So A bar plus B bar. This is how you can find the R bar in the triangular law of vector addition. Triangular law is nothing, it is very easy, it is very basic. Just you need to remember that this is one vector, this is one vector attached head to tail, head to tail. The third vector should be attached like with the tail of the first vector. Like the first and the third vector should be attached either tail to tail or head to head, and that is how you can find the resultant. This was about triangular law. After the triangular law, we have the second law, which is called parallelogram law. Now, for parallelogram law. Parallelogram law. So what does this law states? So parallelogram law states that, for example, if there are two vectors A and B, if the two vectors represent the two sides of a parallelogram. You know what is a parallelogram, right? Like this over here. This is a parallelogram. So let us take two vectors. This is A bar and this is B bar. If two vectors represent two sides of a parallelogram, then the resultant is taken as the diagonal of the parallelogram. So let me explain you this. So let us take, if we have two vectors, this over here, this is A bar, this over here, this is B bar. First step, what you have to do is, you have to complete the parallelogram. So you have to complete the parallelogram. Complete the parallelogram. After completing the parallelogram, you have to take the resultant as the diagonal. This is the resultant vector. So this is only the parallelogram law. If the two vectors are represented as two sides of a parallelogram, then the resultant is taken like the resultant. Here you do not have to take like head to tail, nothing like that. If like you have to take the tail at the center at point O, and then over here the resultant part. So the resultant is taken as the diagonal of the parallelogram. So unlike triangular law, parallelogram law has one formula which can define it. So there is some formula about parallelogram. Let us see about the derivation of the parallelogram and parallelogram law formula and what is the parallelogram. Over here, if we take one vector like this, A bar, this is our second vector, B bar. Here we complete our parallelogram like this. So after completing, if we draw one perpendicular, like this is the point where like all the start, if we draw perpendicular like this will give you a right angle triangle. A bar, B bar, this is the resultant bar. this is O, we can take this as N. This is the R bar, this is the O bar, this is the N, and after that these 2 points also we can specify them as M and N. Now how can you derive the formula for a parallelogram law? So here let us take this the triangle O N and O N P. Let us take this triangle O N P. Triangle O N P. So before moving on, if we are taking this as the theta and when we are substituting the values, here we will get as B sin theta and here you will get B cos theta. How? Let us see. If you are taking this triangle M and P, if you are taking a theta over here, we will get cos theta. Cos theta is equals to base by hypotenuse, so which is equals to MP. MP by hypotenuse, this we can take B. This bar we are taking B bar. So here we can take B. MP by B. So MP we can take as B cos theta. Because MP are taking here, then B will become multiplication. MP by B, cos theta will go to the right hand side. MP is equals to B cos theta. Similarly, when we are taking sin theta, so NP by B is equals to sin theta. NP by B is equals to sin theta. So B is equals to NP is equals to B sin theta. So here we got NP is equals to B sin theta. Here we have the value of A, here we have B. So now in triangle O and P, we have here, if you take A plus B cos theta, here you will get, like if you are taking this angle as alpha, this total value as theta and this value as beta. So what is this alpha? Alpha is that from the x-axis how much is the resultant bar raised. So here in triangle O and P, O1 square is equals to NP square plus OP square. Why? Because here we are using the Pythagoras theorem. ON square, here we are taking ONP triangle, right angle triangle. ON square is equals to NP square plus OP square. Now ON square, here we have taken R bar, right? So R square is equals to NP square. NP is B sin theta. So we have B sin theta square plus OP square, OP. Now we should not take A into B cos theta. Here we have this much, from O to M we have A and M to P we have B cos theta. So we are going to take A plus B cos theta whole square. Now B sin theta whole square is equals to B square sin theta square plus, now A plus B whole square formula you have to use. So A square plus 2AB plus B square. So A square plus 2 into A into B cos theta into B cos theta whole square, which is equal to B square cos square theta. Now this is what value you will get. Now here you have into B square, wait, A square plus 2AB plus B square into AB cos theta. So we have here B cos square theta. Now we have sin square theta, cos square theta. So what we are going to do is we will be taking B square common. If we take B square common, here we will get sin theta whole square or sin square theta plus cos square theta plus A square plus 2AB cos theta. Now over here we know the trigonometric identity, sin square theta plus cos square theta is equals to 1. So this whole value will become 1. We will cancel this out. B square plus A square plus 2AB cos theta, which we can rearrange as A square plus B square plus 2AB cos theta R square. So this is the formula for the parallelogram law of vector addition. This formula is very, very important. Now this can also be written as R. Like if you are removing the square, a square goes on that side, it becomes under root A square plus B square plus 2AB cos theta. This is the formula for parallelogram law of vector addition. What we did, I'll explain you again. Let us take triangle O and P. In this O and P, ON square is equals to NP square plus OP square. Now ON square, here we have taken R value as ON square. So here we took R square is equals to NP value is b sin theta, so b sin theta whole square plus OP value is a plus b cos theta. Now here we have multiplication into b into sin theta, so we multiplied them both, b square sin square theta plus a plus b cos theta, so we have to use a plus b whole square formula, a square plus 2ab plus b square. Now b square sin square theta and b square cos square theta, if we take b square common, sin square theta plus cos square theta, which is equals to 1, so we have a square and 2ab cos theta. So here we got r square is equals to a square plus b square plus 2ab cos theta. One more thing, if in the same triangle you are taking this as alpha, so tan alpha. Now tan alpha is equals to opposite by base, opposite is equals to b sin theta upon base is equals to a plus b cos theta. Like you are taking the same triangle OMP, here you are taking alpha and you are taking tan alpha. Tan alpha is equals to opposite by base, because sin theta is equals to opposite by hypotenuse, cos theta is equals to base by hypotenuse. So opposite by base, so opposite for this is equals to b sin theta and base for this is equals to a plus b cos theta. So a plus b cos theta. So this alpha is with respect to x-axis. If you want to take with respect to y-axis, then you have to take tan beta. Tan beta is equals to again opposite by hypotenuse. Here opposite will be b cos theta upon a plus b sin theta. That is the value of how you can find the tan alpha, which is equals to the resultant. At how much angle is the resultant raised from the a bar. This was the concept about the parallelogram law of vector addition. So we have completed the triangle law and we have completed the parallelogram law. Out of the three laws, triangular, parallelogram and polygonal, this parallelogram law is the most important one, which we'll be using in the whole concept of vectors. Now let us go to the third law, and the third law is called as the polygonal law of vector addition. Now, law. So let us take this point over here. We have a bar over here. We have b bar over here. We have c bar here, and we have d bar over here. One more thing, parallel shifting of vectors are allowed. So what is parallel shifting? If we have b bar over here, we can take this b bar and we can shift it anywhere on the plane without changing its direction. You should not change its direction. You cannot change its magnitude. Only you can take this b bar, you can shift it over here or shift it over there. Direction, magnitude should be same. That is allowed. If we are taking polygonal law, let us arrange them as a bar and then b bar is like this. You take the b bar like this. C bar is like this. We parallel shift the c bar like this. And then d bar is like this. We parallel shift it like this. So don't you find one thing, like one pattern, 1, 2, 3, 4, then you will continue 5, 6, 7, 8. It will make an octagon. But we have only 4 vectors over here. So we have these 4. How do you take the resultant? You take the resultant same like triangular law. All are going in same manner, but the last one you have to take in the opposite manner. So this will be the R bar. That is it. This is only the polygonal law. There is no formula in polygonal law and triangular law. Only the main one and the most important one is parallelogram law. Now we'll be doing some questions and we'll be discussing some special cases, and then we'll wind off with today's session. So let us see. So now we have a question over here, which is two forces whose magnitude is in the ratio 3:5 are given by resultant 28 Newton. If the angle of inclination is 60 degree, find the magnitude of both vectors. So here given a bar is equals to 3:5 means 3x and b bar is equals to 5x. Now to find the angle of inclination, so theta is given 60 degree. That is it. It is very simple. We have to use the parallelogram law formula. And one more thing, R bar is given as 28 newtons. So here we have to take R square is equals to a square plus b square plus 2ab cos theta. So how do you find that this is only like parallelogram law, not triangular law? It is because the ratio is given, the resultant is given, and the angle of inclination, the most important thing, theta will be given, the angle will be given. Then you can find. Plus mostly the questions will only come from parallelogram law, because you have to do the problem only in parallelogram law, because there is no other law has any other formulas. So here a square we have 3x whole square plus b square is equals to 5x whole square plus 2 into 3x into 5x into cos 60 degrees. So 3 square is 9x square plus 5x square is equals to 25x square plus 2 3 is 6, 6 5 are 30, x into x is 30x into cos 60. Cos 60 degree is equals to sin 30, which is equals to 1 by 2. So this is the value. So here we have 2 1s are, 2 15s are. So 9x square plus 25x square plus 15x is equals to r is equals to 20x. So here 2 3 are 6, 6 5 are 30, 30x square. So sorry, it will be square. So here then we have 28 square is equals to 9 plus 25 plus 15. 25 plus 15 is equals to 40. 40 plus 9 is equals to 49. 49x square. Now both sides we have the square. We can use under root. So here 28 is equals to square root this side under root of 49x square. 28 is equals to under root of 49 is 7. Under root of x square is equals to x. So 28 is equals to 7x. X is equals to 28 divided by 7. So out of all doing everything, we get x is equals to 28 by 7 and x is equals to 7 1s are 7 4s are. X is equals to 4. Now we have to find the magnitude of both vectors. So a bar is equals to 3x, which is equals to 3 4s are 12. B bar is equals to 5x, which is equals to 5 4s are 20. Newtons. So thus we got our answer 12 newtons and 20 newtons. So this is what we did. First we found which law we have to use. Then we used the formula. After using the formula, we substituted the value a bar and b bar. After that we got x value as 28 by 7, which is equals to 4. We substituted x is equals to 4 in the place of a bar and b bar, and then we got our answer. Now we are done with this video, because there is one more topic, that is special cases. That special cases we'll be learning in some different video, that is other video. So I hope you have enjoyed today's video. If you have enjoyed today's video and if you have learned something from this video, do share this video, like this video, subscribe to this channel if you are new to this channel, and press the bell icon if you are new. See you next time in the next video. Thank you so much and goodbye.